In this unit we're looking at the particle properties of solids, liquids and gases. Now before we do that, we're going to have a look at some of the physical characteristics and relate these later to their particle properties. So for example, here we've got a solid. You can see that's a piece of granite rock. A liquid being poured into a glass, that's water, and some gas inside a balloon. So what can we say about the shape of solids, liquids and gases? Well, first of all, a solid has a fixed shape, whereas a liquid can be changed. It's easily, and likewise a gas. You can easily squeeze the balloon and change the shape of the gas inside. Now liquids, this liquid's been poured into a container, right? So we can say that liquids, adopt the shape of the container. Likewise, as the gas occupies or adopts the shape of the balloon it's in, we can say that gases also adopt the shape of their container. All right, so look over that. So what about the question whether solids, liquids or gases can flow? Well, clearly you can't pour a solid. Okay, you can pour sand, that's true, but sand isn't a solid, it's a mixture of tiny particles of a solid and air, and that's different. Okay, so you can't pour this rock, but you can pour a liquid and you can pour a gas. We saw clearly that in the video on carbon dioxide, which is quite a heavy, dense gas, you could see that being poured from a glass. What about whether we can compress these? Well, no, you can't compress a solid. You can easily compress, you can easily compress a gas. You can squeeze the balloon, and as we saw in the video on the properties of solids, liquids and gases, you can quite easily squeeze a syringe that contains air. There's no problem with that. But if the syringe contains water, well, no, you can't compress water very easily at all. It will not compress. So liquids are just as hard to compress as solids. Likewise, a volume, well, you can't easily change the volume of a solid, but you can change easily the volume of a gas. As with the syringe, I can quite easily squeeze a syringe full of air, but again, I cannot easily change the volume of a liquid. So if the syringe is full of a liquid, then I cannot squeeze it, I cannot change its volume. Okay, now let's have a look and see how these properties are related to the particle model. Now here we can see a solid and next to it a liquid and the gas, and you can see straight away that the particles in the solid are arranged in a very regular, ordered way. Now just moving over to the liquid, you can see, well, what's happened now is that they are no longer ordered. They are still very close together, really. There's not a really great difference in the spacing, but they're clearly chaotic. There may be within the liquid little patches of order, but as a whole the particles are disordered. And then over to the gas, these particles are very disordered indeed, and there are very large spaces between the particles of the gas. Now the spaces here do not, this diagram is a bit confusing really, because the spaces between the particles are really much larger than this, than is represented in this diagram. Okay, so we need to be clear about that. So very large spaces between the particles of a gas. Okay, Now, what about the forces that hold solids together? Okay, so we can say that they're held together by very strong forces hold them together. And the liquid, well, the liquids are held together by forces, but the forces are weaker. Okay, so just think of a raindrop, for example, falling through the sky. Well, something must hold the particles in that raindrop together, and in fact, yes, the particles are held together by weaker forces. And a gas, well, there are no forces acting on the particles of a gas. And then, as we said earlier, clearly the spaces between the particles of the solid are very small. Again, liquids, they're small, and the gas very large. Now, changing position. How about what about the particles in a solid? Well, just take this chap here in red. Now, what are these particles doing all the time? Well, they're continually moving. They're vibrating. They're vibrating around on the spot, but they are unable to change position. So this red particle here cannot go where it wants to. It has to stay here, fixed within what we call the lattice, really, and it cannot move where it wants. Whereas in the case of the liquid, this red particle can go where it wants. It can wander around and it can change position, and that is precisely the explanation of the properties of a liquid compared to a solid. You can pour a liquid simply because the particles in the liquid can change position. A liquid occupies the shape of its container because these particles can change position. So we can relate those properties to the particles themselves. So change position, nope, okay, yes, and again in a gas, yes, it can. The particles of a gas can easily change position. And finally, yes, we've ordered, whether ordered, yes, they're very ordered, no, and no. Again, we can also relate, for example, the question of whether or not we can compress solids, liquids or gases. Well, you can see clearly here that gases are easily compressed. They're easily compressible simply because they have large spaces. There are large spaces between the particles. Whereas liquids and solids, well, they don't have large spaces, so they're not easy to compress. And likewise, with volume, for example, you can change the volume of a gas because there are large spaces between the particles, whereas you cannot with a solid or a liquid. You cannot easily change their volumes because there are not large spaces between the particles. There are very small spaces.